Alright, so as I said in the previous video, we're going to go through a bit of a work example here. It's going to be a very simple work example, but it will hopefully reinforce how these equations can be used in the most basic way. So sometimes it's easier to start off in the basic way and then work for more advanced methodologies later on. So let's have a look. So we have up the top, we've got Dalton's Law. So Dalton's Law, I'll just underline it up the top. So we've got Dalton's Law is pressure total, PT, equals the partial pressure of A plus the partial pressure of B plus the partial pressure of C. So all of the different pressures of each of the molecules that we're going to have, all squeezed in together, will equal the pressure total. Very simple. So I'll just go through this example here that I've written out. So an airtight room contains 3 different types of molecules, and they're in the following quantities. So we've got 2 moles of O2. So let's write it out as we're going. 2 moles of O2. We've got 2 moles of N2. And we've got 6 moles of argon. Okay. What are each of their partial pressures given that the total pressure of the room is equal to 1,000 torr? So let's write out also that the total pressure, so pressure total equals 1,000 torr. So all torr is just a unit of measurement. Okay, for some places we've got meters, for some places we've got liters. For pressure, we're talking torr. Okay. So this is the information we've got. 2 moles of O2, 2 moles of nitrogen, and 6 moles of argon. And the pressure total is 1,000. So it's the first thing we want to do, so step 1, go through it step by step, is we want to convert the moles that we have to a mole fraction. So if you recall from the previous video what the mole fraction is, so the rule for the mole fraction was XA, so mole fraction equals the number of moles of A divided by the number of moles total. So let's work that out. So we've got the mole fraction, we'll do oxygen first. So the mole fraction of oxygen equals the number of moles for oxygen, which was 2. So NO, O2, over the number of moles in the total system. So the total for the room is equal to 2 plus, remember what the total was, it's all of those added up together. So we've got 2 plus 2 plus 6, so which adds up to 10. We can simplify 2 over 10 to 0.2. We can just do that in our head. So we've got our 0.2. So that's what the mole fraction is. The second step, okay, is to convert. We want to find, what did we want to find originally? So let's go up. We originally wanted to find what each of their partial pressures are, given that there's 1,000 torr in the room total. So the partial pressure of oxygen, O2, is going to equal, so this is what we want to find, okay? This is what we're looking for. It will equal the mole fraction of O2 times the pressure total. Now have a think about it. We don't know what the partial pressure of oxygen is at the moment. What do we know? We know what the mole fraction is. It was about 0.2 that we found earlier. So mole fraction is 0.2. What was our pressure total? 1000 torr. 1000 torr. So pressure of O2 was 0.2 times 1000? 200. 200 torr. Now I could go through the next two molecules and bore you, but you've got the gist of it there. So if we go through it very quickly, we know that 2 moles of nitrogen, that's going to work out exactly the same. So 2 moles of nitrogen is the same as the 2 moles of oxygen, and your 6 moles of argon, well, that's going to be 3 times as much. So you're going to have, so your nitrogen, pressure of nitrogen is going to be 200 torr. And what's our pressure of the other one, the argon? It's going to be 600 torr. And if you add those all up together, it's going to equal what we were looking for originally, 1000 torr. Okay, so there is a quick example, a simple example of how Dalton's law can be used in a common question, and going through it very slow. So I hope slow works for you, because sometimes I find that on the other websites or on the other YouTube videos, they can go through it very quickly, and you can miss up on the steps. So yeah, I hope you enjoyed that and that was helpful for you. Thank you.